as a little bit of a review, we know that if we have some function, let's call it f. We don't have to call it f, but f is the letter most typically used for functions. That if I give it an input, a valid input, if I give it a valid input and I use the variable x for that valid input, it is going to map that to an output. It is going to map that or produce, given this x, it's going to produce an output that we would call f of x. And we've already talked a little bit about the notion of a domain. A domain is the set of all of the inputs over which the function is defined. So if this is the domain here, and I take a value here and I put that in for x, then the function is going to output an f of x. If I take something that's outside of the domain, let me do that in a different color. If I take something that is outside of the domain and try to input it into this function, the function will say, hey, wait, I'm not defined for that thing that's outside of the domain. Now, another interesting thing to think about, and that's actually what the focus of this video is. Okay, we know the set of all the valid inputs, that's called the domain. But what about the set of all of the outputs that the function could actually produce? And we have a name for that. That is called the range of the function. So the range, and the most typical, there's actually a couple of definitions for range, but the most typical definition for range is the set of all possible outputs. So you input something from the domain, it's going to output something, and by definition, because we've outputted it from this function, that thing is going to be in the range. And if we take the set of all of the things that the function could output, that is going to make up the range. So this right over here is the set of all possible outputs. All possible outputs. So let's make that a little bit more concrete with an example. So let's say that I have the function f of x defined as, so once again, I'm going to input x's, and I have my function f, and I'm going to output f of x. And let's say the function definition here, the thing that tries to figure out, okay, given an x, what f of x do I produce? The definition says f of x is going to be equal to whatever my input is squared. Well, just as a little bit of a review, we know what the domain here is going to be. The domain is a set of all valid inputs. So what are the valid inputs here? Well, I could take any real number and input into this, and I can take any real number and I can square it. There's nothing wrong with that. And so the domain is all real numbers. All real numbers. But what's the range? I'll do that in a different color just to highlight it. What is going to be the range here? What is the set of all possible outputs? Well, if you think about it, actually, to help us think about it, let me actually draw a graph here of what this looks like. So the graph of f of x is equal to x squared is going to look something like this. So it's going to look something like this. I'm obviously hand drawing it, so it's not perfect. It's going to be a parabola with a vertex right here at the origin. So this is the graph. This is the graph y is equal to f of x. This, of course, is the x-axis. This, of course, is the y-axis. So let's think about it. What is the set of all possible outputs? Well, in this case, the set of all possible outputs is the set of all possible y's here. Well, we see y can take on any non-negative value. Y could be 0, y could be 1, y could be pi, y could be e, but y cannot be negative. So the range here is, we could say it a couple of ways. We could say f of x, let me write it this way. F of x is a member of the real numbers such that f of x is greater than or equal to 0. We could write it that way. If we wanted to write it in less mathy notation, we could say that f of x is going to be greater than or equal to 0. F of x is not going to be negative. So any non-negative number, the set of all non-negative numbers, that is our range. Let's do another example of this just to make it a little bit clearer. Let's say that I had g of x. Let's say I have g of x. I'll do this in white. Let's say it's equal to x squared over x. So we could try to simplify g of x a little bit. We could say, hey, look, if I have x squared and I divide it by x, that's the same thing as g of x being equal to x. X squared over x is x, but we have to be careful because right over here, we have to, in our domain, x cannot be equal to 0. If x is equal to 0, we get 0 over 0, we get indeterminate form. So in order for this function to be the exact same function, we have to put that, because it's not obvious now from the definition, we have to say x cannot be equal to 0. So g of x is equal to x for any x as long as x is not equal to 0. Now these two function definitions are equivalent. And we could even graph it. We could graph it. It's going to look, I'm going to do a quick and dirty version of this graph. But it's going to look something like this. It's going to have a slope of 1, but it's going to have a hole right at 0 because it's not defined at 0. So it's going to look like this. So the domain here, the domain of g is going to be x is a member of the real numbers such that x does not equal 0. And the range is actually going to be the same thing. The range here is going to be, we could say f of x is a member of the real numbers such that f of x does not equal 0. F of x does not equal 0. So the domain is all real numbers except for 0. The range is all real numbers except for 0. So the big takeaway here is the range is all the set of all possible outputs of your function. The domain is a set of all valid inputs into your function.